Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to continue the same topic, image generation. As we dive deeper into the exciting world of AI and machine learning, these papers reveal some of the most innovative advancement in image generation, motion synthesis, and 3D reconstructions. By introducing cutting-edge techniques, they open new doors for personalized, accurate, and creative AI-driven experience. Dear friends, let's explore these breakthroughs that are transforming the landscape of AI. You can find the full paper link in the description. And of course, dear friends, if you reference these papers in your research, make sure to cite it. The first paper we are going to discuss is Subject-Diffusion, Open Domain Personalized Text-to-Image Generation without text-time fine-tuning. Different Subject-Diffusion takes personalized image generation to the next level by allowing user to generate images with only a single reference image, without the need for fine-tuning during the generation process. The model's ability to handle open domain generations where it can generate images for any subject makes it incredibly versatile. The authors use the LAION, L-A-I-O-N, that is aesthetic dataset with 76 million images and subject annotations like bounding box and segmentation mask, enabling the model to generate highly personalized images, even with multiple subjects. The real innovation comes from combining coarse locations information and fine-grained reference image control. So this means the model not only captures the subject fidelity but can generalize well across the domain. With an attention control mechanism, it can even manage multi-subject generation effectively. In practical terms, the model is superior to existing state-of-the-art methods, performing better in single, multi, and human customized image generation. It pushes the boundaries of personalization in text-to-image synthesization. Okay, the next paper, it is diffusion sampling with momentum for mitigating divergence artifacts. Despite the impressive image generation quality of diffusion model, the slow sampling process has been a change. Many methods have tried to accelerate diffusion sampling by reformulating it as an ODE or SDE system. Difference, however, they still face divergence artifacts, especially when using fewer sampling steps. This paper presents two novel techniques that tackle these artifacts hits. The first innovation is the incorporation of heavy ball, HV momentum, a classical optimization technique. By adding momentum to diffusion methods, the authors expands their stability regions, leading to more accurate results. The second technique is the generalized heavy ball, that is DHVB. That exact method offers a trade-off between accuracy and artifact suppressions, giving users more flexibility. With these improvements, the model significantly enhanced the quality of image generation, even with low step sampling. This paper opens the door of faster, higher quality image generations with a diffusion model, setting a new standard for future sampling methods. Okay, next it is all about interpolating between images with diffusion model and of course the difference I want to just specify in the world of image generation, interpolation between two distinct images has been underexplored. So this paper introduced an innovative method that leverages latent diffusion models to interpolate between two images using a zero-shot approach. So the key idea is to interpolate in the latent space at various noise levels, blending the future of both images in a seamless way. So this approach can be extended to varying subject poses and image styles, creating highly diverse output. The authors further enhance consistency by generating multiple candidates and selecting the best one using clip for image quality. Towards the result, convincing interpolation that spans a wide range of style and content. So this paper also critiques traditional metrics like FID, so arguing that they are not sufficient to evaluate the quality of interpolation, further pushing the boundaries of creative image manipulation. This work significantly expands the creative possibilities of image generation and editing. As next paper, it is Points to 3D. Yes, bridging the gap between Sparse point and Shape-Controllable. Text to 3D generation, that is Point to 3D, introduces a breakthrough framework for text to 3D generation, combining the power of 2D diffusion model and 3D model to create more realistic and controllable 3D shape. Traditional methods face challenges with view inconsistency and uncontrolled shape when generating 3D. Dear friends, here Point to 3D solves this by using Sparse 3D point from the Point 3D diffusion model as a geometric pair. And the model guides, of course, a neural radiance field. Of course, we have discussed this in the previous episode. So NERF with these sparse point to ensure a view consistent appearance and a better shape control. The authors further enhances this by optimizing the depth map and performing score distillation from the 2D image diffusion model. The result is a significant improvement in the consistency and realism of 3D generation from text, making it a powerful tool for a wide range of application. And here Point to 3D makes text to 3D generation more controllable and precision, so setting a new standard in the field. Okay, next it is TEDi. Temporally-Entangled diffusion for long-term motion synthesis. Dear friends, TEDi introduces an exciting new method for motion synthesis, particularly for generating long-term motion sequence in character animation. It builds upon the concept of denoising diffusions model, that is DDPMs, but adapt it to work along the temporal axis of motion. Instead of iterating over just the image features, the TEDx works on denoising motion buffers, producing frames one by one. And here TDS unique formulation involves entangling the temporal axis with the diffusion process, allowing for the generation of arbitrary long sequence. It iteratively denoises the motion sequence, removing noise from the oldest frame while adding new noise to the buffer. So this method paves the way of high quality, long duration motion synthesis. Ideal application for this character animation, gaming and film productions also. This would be very much useful. And here TEDi opens the door to more natural continuous motion generation, offering a fresh perspective on temporal anthesis. And that's a wrap up of today's exploration of the latest advancement in AI-driven image generation, motion synthesis and 3D reconstruction. And dear friends, these papers pushes the boundaries of what's possible in the field, from personalized image creation to long-term motion generation. As AI continues to evolve, the possibilities for creative expression and technical precision are endless. If you enjoyed this deep dive, make sure to like, share and subscribe for more updates on the world of AI. And I would love to hear your thoughts in the comments below. And if you come across any papers related to this topic discussed, so feel free to share them with us. And thanks for watching. See you in the next episode. Thank you, dear friends. Happy learning.